Welcome to this video. This is on chapter 7 of the syllabus, and this is acids, bases, and salts. First thing we've got to talk about really is what is an acid. Okay, well, I think the best thing we can do is look at an example. Let's have a look at HCl. All right, hydrogen chloride. Let's draw hydrogen chloride. There's the hydrogen. Let's make the chlorine green. Oh, there's the chlorine. Okay, this is my hydrogen. This is my chlorine. Let's do the electrons. Electrons. Okay, will look something like this. Okay, and this is a hydrogen chloride molecule. All right, so we describe this as HCl, and it's a gas normally, and it's called hydrogen chloride. All right. Now, interestingly, let me move this up a tiny bit. Interestingly, if you dissolve this in water, what happens is, all right, let me draw my beaker. There's the beaker. And if I dissolve this in water, this bond here breaks. Okay, the bond breaks. All right, and we end up with hydrogen and chloride. Okay, so let's redraw the labels. Oops, H and Cl. Now, interestingly, the chlorine takes the electrons from the bond. Okay, so it ends up as Cl minus. And the hydrogen, well, if it lost an electron, it's H plus. Okay, now this is when it's in water. So let's draw the surface of the water there. All right, so up here we have the bonding is covalent. And down here, it's ions, isn't it? So we could call this ionic. Okay, and the bond breaks, and there you go. All right, so let's draw this out in an equation where we have HCl gives us H plus and Cl minus. Okay, and now this solution at the bottom is now HCl aqueous because we've dissolved it in water, and we call this hydrochloric acid now. All right. Now, as you can see, it gives away this H plus. All right, and this is known as a proton. Okay. If you kind of don't know that, it's a hydrogen ion. And why is a hydrogen ion a proton? Well, that's easy, really. If you think of a hydrogen atom, it's electrons surrounding a proton. There we are. There's my electron surrounding a proton. This is a hydrogen atom. Okay, but if I take off the electron, we end up with just the proton. Okay, so a hydrogen ion is actually just a proton. Okay, now this guy here, HCl, has given away its proton, which split up to give a proton and a chloride ion, and that's why we call a definition of an acid is a proton donor. It donates a proton. Okay, and there is the proton. All right, now this solution is now acidic. Okay, why is it acidic? Because it has free H plus ions in it. All right, if you have H plus ions in something, the solution is acidic. So this process here of this bond breaking is known as dissociation. So we say it dissociates. The HCl molecule dissociates to give H plus and Cl minus. Now this is what acids do. They dissociate to give protons. All right, now have a look at the other two famous lab acids. You have nitric acid, okay, and we've got sulfuric acid. Okay, now these guys break up to a proton and a proton, and the nitrate ion there, and the sulfate ion here. All right, now as you can see, this is two hydrogens here, so this gives off two protons. All right, so all acids dissociate to give protons. This one gives one proton, and this one gives two proton. Things that give one proton, like HCl and nitric acid. All right, the old-fashioned term for this was we used to call them dibasic because sorry, that's rubbish. We used to call them, let me get rid of that, monobasic. Sorry about that. We used to call these monobasic. And the reason we call them monobasic because they gave one proton. Mono is one. They give one anti-basic group at one proton. All right, but the new term we use for these is we say they are monoprotic monoprotic, which is a better term really. So these are monoprotic acids. What does that mean? They give away one proton. Sulfuric acid, as you can see here, gives away 2 protons, and this is known as a diprotic acid. Okay, so there you go. That's what an acid is. It's a proton donor or a hydrogen ion donor. Why do they give away protons? Well, they dissociate when they're added to water. So what is an acid? It is a proton donor when dissolved in water. Interestingly, in the covalent form, okay, it is a non-conductor. Okay, but it's in its ionic form. It has ions, and therefore in the ionic form it will conduct. And we can electrolyze a solution of HCl or nitric acid or sulfuric acid. But in the covalent form, they are non-conductors. Okay, they're non-conductors in the covalent form. Okay, that's enough for this video, I think.